Have you ever wondered why you were in this world? Or just think about how things work in sync? Or maybe thinking about how things work perfectly fine? Well, all of these thoughts can be funneled down in a single word: function. So in this video, we'll try to understand how function works and how it affects our daily lives. But before that, the following are the objectives of this video. Number 1, represents real-life situations using functions, including piecewise functions. Number 2, evaluates a function. 3, performs addition, subtraction, multiplication, division, and composition of functions. Number 4, solve problems involving functions. In this video, we're gonna be discussing the following: definition of function, types of function according to terms, types of function according to degree, special types of function, piecewise function. Function is one of the most wonderful concepts on math. It has a wide variety of application in the real world, ranging from the smallest grain of sand and up to the vast space of our universe. It also lives with you even on your morning coffee. The process of mixing up sugar, coffee, and hot water up until by sipping it to be a part of your system is still a function. Well, on my view, this has the most application in the real world. You can actually see it unlike any other math topic you had been experienced. Outside the realm of math, the word function simply refers to what something does. But in math, the word function has a more specific meaning. In math, a function is basically something that relates or connects one set to another set in certain way. Remember that a set is just a group or collection of objects. It is often a collection of numbers, but it doesn't have to be. A set could be a collection of letters, names, colors, or just about anything. So since a set is just a group of anything, how about a function relates to of which? On our previous lesson, we talked about what relations are. Well, function is one of it. Subsequently, function has also the so-called inputs and outputs, or sometimes we called by special math names, domain and range respectively. A relation could only become a function if its inputs result to just one output. Thus, a function is also defined as a kind of relation in which every input, there's only one output. Everything in this world is a combination of a cause and effect relationship. In math, cause is called the input. While the effect is called the output. For instance, let's have two sets. The first set is a set of collection of shapes. The next set is a collection of numbers of sides. By looking at the two sets, we can simply infer that the triangle is related to 3 and the square is related to 4. Therefore, each of our input only have one output, or called one-to-one relations. That means the arrows from set A don't reach nearly two members of the set B. That's how functions are. Another thing with function is that even you have a different inputs, you can still have a single output, or many-to-one relations. Yet, that's still a function. Let's put it this way. Let's say you're the luckiest man in the world, and as you are walking by, you saw a casino. You tried to play the slot machine. You then try a gold coin and inserted it out on the machine. You wait until the process stops. The machine spits gold coins, which means you had won the game. You tried it again, but with a different coin. You inserted it on the machine and wait again until the process stops. The machine now drops gold coins. The gold and silver coins here serves as your input. As you play it out on the machine always discharges gold coins. By sorting out all information, we can say that inputs here develop same output. And yes, it is still a function. Most of the functions that you will encounter on math will be a little more abstract than any examples I showed. Like this one. 5x is equal to y. This time, we say that the x is a set of numbers that we choose as inputs or domain, while y is a set of numbers that we get as results or range. With this example, we can input any number at all to be our x and get its corresponding outputs to be our y. Let's say I chose 2 as x. Definitely, I could get 10 as y. It is because if you multiply 5 by 2, the result will always be 10. Most of the time, functions follows a notation in which the y is replaced by f of x. For instance, our example will become f of x is equal to 5x. Functions are named by number of terms or by degree. Let's talk about first how functions are named based on its number of terms. What is a term? Terms in a function is a part of it that was separated by the symbols plus or minus. In this type, functions can be named as monomial, binomial, trinomial, and polynomials. Monomial has a prefix of mono, which means one. Therefore, it has only one term. Binomial has a prefix of bi, which means two. Therefore, it has two terms. Looking at the example, the two terms was separated by a positive. Trinomial has a prefix of tri, that means 3. Therefore, it has 3 terms. Lastly, polynomial. Polynomial is a general name for a function, but it is often used for the functions with 4 or more terms. Another way of naming a function is by how big its degree is. What is a degree? Degree is defined as the highest exponent that an input has. Naming a function by degree has 3 basic kinds, which are linear, quadratic, cubic. First, let's have a linear function. A linear function has a degree of 1. As you can see on the example, there's no exponent written on the variable x, or our input. Well, it's not actually missing, but basically, it is not written anymore, and math accepts it as 1. Linear function has a graph called line, hence its name linear came into place. The graph of a linear function looks like this. Linear function is pretty much famous as you observe the real world. You can see it on the roads or almost on all surroundings. Almost any situation where there is an unknown quantity can be represented by a linear function, like figuring out incomes, calculating mileage, or even predicting profit. Many people use linear functions every day, but not by drawing a line. Instead, by having calculations on their head. Linear functions can be seen well in high-rise structures like buildings, towers, and hotels. Another type of a function called by degree is a quadratic function. A quadratic function is a function whose degree is 2. As you can see on the example, there's an exponent on one of the x, written as 2. Quadratic functions have a graph called parabola, and it looks like this. It is a bell-shaped curve along y-axis. Parabolas were mostly used on infrastructures that holds excessive amounts of loads. It could come on the shape of a bridge which holds massive weights of vehicles passing by. Also, quadratic functions are being applied on antenna, automobile, and even design of ballistic missiles. The last type of function according to degree is the cubic function. A cubic function is a function that has a degree of 3. The graph of cubic function is a curve that looks like this. Unlike the first two kinds, cubic function is mostly used on solutions rather than figures. Engineers use cubic function to find electrical resistance or how a device reduces the current flow. It is also being used by astronomers to describe the motion of the planets through the space. Cubic function is also very useful on getting the volume of three-dimensional objects like sphere, cube, or prism. There are also functions that seems to be special unlike the others. Check them out. So the real deal with these special types of function is what we call piecewise functions. Piecewise function is a tricky one because unlike any other function, this was made up of two or more different type of functions. And it was bounded by different domains. So since it was made up of different functions, the graph of it looks like puzzle pieces. Therefore, the graph of piecewise function has no definite shape. Piecewise function looks like this. So the first side is called expressions while the right side is called restrictions. So restrictions are the domains bounding our piecewise function. This means that x minus 2 is only for x is greater than 4. So the so is true whenever we choose any kind of expression of our piecewise function. The graph of a piecewise function looks like this. How do we graph piecewise function? Let's say we graph f of x is equal to x minus 5 if x is greater than 3 and x squared if x is less than or equal to 3. For step 1, we should get a part. Graphing piecewise function takes time, so that we should graph the function by part. So, for instance, I chose x minus 5 and x greater than 3. The next step is we have to identify the critical number. Critical number is the constant present on the restrictions. After getting your critical number, you should construct a table of value. You have to choose your numbers on the x, and it must follow the restriction and must start with the critical number. So since we should start with the critical number, therefore we should start at 3. Since our restriction states that x is greater than 3, therefore we should choose numbers greater than 3. And then you will substitute our chosen number to x and get the corresponding results to be our y. And this will be placed on the y column. For instance, x minus 5, and then we substitute 3, so we will have 3 minus 5. And the result will be negative 2. Then negative 2 will be placed on the y column corresponding to the x used. Continue the process up until you have completed our table. Next is combine all corresponding x and y to make up the point. 3, negative 2, 4, negative 1, and 5, 0. After finishing one part, you need to repeat steps 1 to 3 for the remaining part. So, x squared if x is less than or equal to 3. Get the critical point and then construct a table of value. So I chose numbers 3, 0, and negative 1 for the second part because our restriction states that we have to choose numbers starting from 3 and less than. You can pause the video and try it on your own to complete the table and check if we have same answers. After completing the table of each part, you need to plot the points on a single graph. After completing such steps, our graph will look like this. The red graph is the graph made by table number 1 or part A, while the blue graph is the graph made by table number 2 or the second part. You can observe that the arrowhead of each graph is being directed by the restriction given. Red graph has a restriction of greater than, that's why the arrow points to the right. While the blue graph has a restriction of less than or equal, that's why the arrow points towards left. You can also observe that on the critical number 3, there's a hollow point on the red graph and a solid point on the blue graph. It is because the restriction for the red graph has only the symbol of greater than, while the restriction on the blue graph has a symbol of less than or equal. In general, for critical numbers, if the symbol is just greater than or less than, you should use hollow point. If the symbol is greater than or equal or less than or equal, you will use a